Hi guys, Ashwin here, and today we are going to continue with episode 2 of Sui Deep Dive series. And today we will learn about one-time witness pattern and witness patterns in Sui move contracts, and why it is necessary in the Sui ecosystem, and as well as how we can utilize the objects in Sui, like shared objects or owned objects, how it works in the token module contract that we are going to build, and how we are going to maintain the access control between different entities like admin or owner slash multiple. Say if we have a token module contract and we have multiple access controls, then this is very much necessary, and let's get started. Okay, so we can get started with what is witness pattern and what is one-time witness pattern. And before moving on to that, as we already know about owned objects and shared objects, owned objects is going to be just with, say I have a token module, and the owner cap, the single owner cap object is going to given to owner one, and admin cap is going to given to admin one. Okay, so these two objects are something like owned objects, right? So only one single entity can hold the single object. So let's say I have a token module contract, and I have a min function, and it is having some access control, say owner cap. This can be called by the owner only, and he should have the owner cap of type owner cap. Okay, we are going to reference it right now. And okay, so this is the min function that owner is going to call. Let's say in some token modules, in some random token module, it's going to this min function is going to handled by two entities, owner cap and the admin cap. So it's going to be exactly like owner and admin, both of them should access the min function. How it's going to look is, here witness pattern comes into picture. So what is witness pattern is, let's say I have another function, say witness gen from owner and mint. Okay, this is the function, and let's say this function is called by the owner. This is called exactly called by the owner because we restrict it with the owner cap. And I'll say why we need this kind of security as well. Okay, owner, and type owner cap. Okay, this this function is called by the owner, and here we have another function, witness gen. Okay, so witness gen owner, and then we have the min function here. Now what I'm doing is I'm going to restrict here this thing, and I'm going to replace it with this method. So what it's going to give me is, this witness pattern basically gives you an object. So whenever you call a witness function, it's going to give you an object which has drop capability, and I will explain what is drop capability in a second. So the exact object can be used to access the mint function, and that after you access the mint function, the object that you created via the witness function will be dropped, okay, at the end of the mint function. So this is the concept of witness. And why we are doing this, that is another thing, because we have another way, right? Say you can ask Ashwin, why you can you can use an admin registry or some other registry object to have the owner addresses stored here, and admin address stored here, and in the min function I can say assert either owner or admin. But so here it is a single point of control we are giving. So via code we are making it something like I'm giving access control via code only, and if we want to make it still more secure, then we go with witness pattern, which obviously how it's going to do is we have two controls here, right? So only the guy who is having the witness pattern, witness object can access the mint function. So witness gen owner basically gives you, you know let me show you that. It's going to, this is the function, say it's going to assert whether you are the owner, and then it's going to give you the exact object, owner witness. Okay, it's going to return this, and this which has a drop capability, as, sorry, one second, we will see the abilities still, to be very specific, drop ability. Okay, so yeah, this owner witness is being returned, and this owner witness is used to enter the mint function. Then after you enter the mint function, you mint some tokens, then the owner witness is getting dropped here. Okay, so sorry. Okay, you use this owner witness to call this mint function, and the mint function, after it's getting to the end of this line, it's going to drop the owner witness. Okay, since the owner witness struct has the ability drop. Okay, so this is what witness function is actually means. So this is one kind of useful pattern that we can use in the token module, or any kind of contract which has multiple access controls. This is the first thing that I wanted to mention. Now next up, we will directly jump into the code base, and we will code the one time witness token module. So what is 1TW? 1TW is, that's one time witness. And after we complete the token contract, we are going to deploy it on the testnet, and we are going to see how it works. And then later we are going to see the documentation of the one time witness pattern and the witness pattern, to just give a brief out of it. And while we code along, we are going to make sure that you can be familiar with visibility criteria that move follows, say public, private, or entry functions. Then we have the abilities, to be very specific, key, drop, and store. Yeah, that is then copy. Yeah, let's jump onto the code base then. So this is our code editor. I have just initialized a new move file, and let me show you how we can do that. And something random file for now, because I'm going to delete it. So as you can see, random file is already here. Let me see what's inside. Just I want to show you guys. Okay, so let me show from here only. So random file.move, and test. This is the file space where you're going to write test cases for your source contract, and git ignore files, and toml file. So here I can be very specific here, say okay, toml file. Then what exactly the structure would be is module, and the name of the contract. So to be very specific, the address of the module and the name of the module. Sorry, okay, that's the thing. Module name and the address, right? Sorry, this is the address, and this is the name. Now it's the format. Okay, and okay, this is going to be the format. So what I'm doing is I'm making an alias for the address here, alias for the address, random file, and random file will be the random file. Yeah, so this is how we will be initializing the module, and the module boilerplate. And so that what happens is we assign the module to an object. So to be still more understandable, you can assume every contract is an contract or module is an object. Okay. Okay, so this is the one, and I'm going to remove this. I'm going to delete this now. Sort of random file. Okay, I'm removing. I just removed it. And another one thing I need to mention is, say I am in EVM. What we do is, we have contracts, right? Multiple contracts, and in Sui side we have multiple modules, which is like division of multiple functionalities, and we call a package, to just a group of modules. Okay, so this is something it will be useful for you guys, so I'm just putting it out here, and yeah, I'm just removing it. And yeah, let's get started with the witness pattern, one-time witness pattern. And so as we discussed about witness pattern, what one-time witness pattern is different from witness pattern is, so witness pattern can be used multiple times around the lifetime of the module. So module is going to be living forever in the chain, but whenever the owner comes in and generates a witness and calls a mint function, then he can come again and do the same process with a single owner cap. That is the process here, right? So Sui specifically suggests the developer to use one-time witness for token module contract. I'll get I'll come to this in a meanwhile. I'll talk about this why in specific. So after we code along. Okay, so now I'll just initiate my module, and let me take a look in my toml file, the address name, the alias. Okay, it's token, and token. I'm going to name the module as token. Okay, and then what I'm going to do is I'm going to initialize a struct. Okay, every object, every struct is something we need to have it as public. It's the move 2024 update IG. So public struct, and I'm going to initialize the token, and it's going to be something without fields. It's going to be empty. Invalid one-time witness declaration. One-time witness can only have the drop ability. As I previously mentioned, there are some rules to be followed to have the one-time witness to be saying. So one is the struct should have the drop ability, and another thing is you use the witness, that is this exact token, in the init function, so that you generate one treasury cap. I'll get to what is treasury cap in the meanwhile. So we call a function called create currency from the coin module, coin module, and this is going to return a treasury cap of type token in our case, and also the metadata. I'll say what is metadata in a second, and when we code along. So this treasury cap is the entry for whatever I'll be giving an example. Take an example. I'm deploying this contract. When I deploy, I get the treasury cap. I'll code it in this way. I'll send the treasury cap object to the sender. Sender in the sense, the one who initiates the transaction. Okay, so this treasury cap, whoever is holding has the access to burning or minting the tokens, the the most crucial operations in token module. So which is, say, it has a drop capability, and we compile it. That is, let me restart the window. Okay, so I've just initialized my coin type. Initialize the coin type. Next up, what we are going to do is we create a treasury object. Why we are going to create a treasury object? So we are going to create a treasury object. Say there are multiple tokens involved in a module. Okay, so let me assume that I have a LP contract and there is multiple tokens involved and I need to store the tokens in the contract. To be specific, we have coins, right? It is mentioned as coins in the Sui ecosystem, and I need to store the to be very understanding, I'll call it as tokens in the contract. So what I'll be doing is I'll create an object called treasury, and I'm going to have the coins stored in the treasury object. That is one kind of way that we can use, have treasury objects as vault. Okay, vault or treasury object. That is one way of using it. Or another way is, as we know, we can have treasury object, or we can have other to say there is no need for having only objects in your module. You can have struct data structure, just the data structure is enough. So I'll just tell when the struct becomes an object and when it doesn't. Okay, so here comes the abilities part, abilities that we assign to a struct. So let's say there are I'll just give it something like this: key, drop, copy, then what else we have, store. Okay, this is the 4 capabilities that move struct can have, and I'll tell you what is one by one. And key is the higher level. We'll come to this in the next step. So drop, as we have said in the previous section, so when a function is it's going to get in the end of the line, it's going to finish the exact struct which has the ability drop. It's going to get dropped automatically in the end of the line. So that is the drop ability. Drop abilities struct gets dropped, something like. Okay, I have explained it. So, and copy is just you make a clone of the object or DS. Okay, DS is data structure. So it is very much similar to having clone in Rust. And store is nothing but say I have a struct Ashwin, and his character. I need to define that it is a character, it is a field, and I'm going to assign an object to it. So okay, this is the thing. So when I am going to assign an object, assign an object to a field, and which is internally in a field, then I need the store ability. This store ability should be assigned to this exact character object. Okay, so store ability, and it's assigned to the store object. To the object which is gonna be stored in another object. Maybe my comments might be slightly weird, but you get the point, right? Yeah. Okay, these are the abilities, and let's get into the transfer primitives as well. So when we talk about transfer primitives, there are mainly, we'll cover some main primitives. Okay, public transfer, public freeze object, freeze object. Then what else we have? We have just just the share object. This naming convention, this exact third one might be wrong, but I'll just explain it on the go. So public transfer, there is another transfer primitive, which is just the transfer. Transfer primitive, you can I'll explain the public transfer first, and we'll go to transfer. So public transfer, you use it for generic types. You use for generic types. You use for generic types. It can be of any object type. Okay, so not only very specific of how transfer primitive is going to operate. Using transfer, you can target the coin. Coins like Sui, Sui. This can be transferred using the transfer primitive itself. Transfer primitive. So this is the difference between public transfer primitive and transfer primitive. And public freeze object, what it does is, whatever object that you pass in is going to be immutable, and can't be dealt with, which is you can't delete it. Okay, this is the freeze object definition. And share object is, this is where we share the object to Sui global storage, and anyone can access it. So this is called shared object. So yeah, and example LP. Okay, liquidity pool. So here in Sui we have the liquidity pool as objects, right? So liquidity pool itself is an object, and we are going to have tokens in the liquidity pool. Yeah, now let's get started with the one-time witness pattern. So I just wanted to cover this, a basic intro of how it's gonna look when we code. It's going to be a simple token module in the beginning. Then later on we use these concepts over the time period, and we make a full-fledged token module, or some good token module which has some upgrade capability. So the token module which has the upgrade capability is not good, because you don't make the trust between, you don't create the trust between the token module and the community, right? So if it is a meme token, then that's fine. Anyways, you are going to rug pull it. If it is a legit token, then you don't need token module, upgrade capability. Don'ts. Okay, I'll have it as don'ts, and no upgrade capability, no usage. We need to delete it to be very specific, very important. And I've just cleaned the code base, and copied the notes to the text file, and let's continue. I'm going to create the treasury object, and this treasury object is going to have a key ability, and whenever you have a key ability in move, you make sure that you have the UID and UID. Then what else we need for now? Okay, treasury address, treasury val address to be very explicit. Treasury wallet address, and it's going to be of address data type. Yeah, okay, my system is okay. This is the first thing. Then I'm initializing the treasury. And what we are going to do is we are going to call the init function. Now we are going to write the init function down. This is very much similar to EVM's constructor. So whenever the deployment happens, we this init function is triggered by the VM. Okay, so this is going to be a private function, and also I will explain the visibility criteria as well here now. Criteria, which is public, private, and entry. So public functions can be called outside the module, which is our module. You can call from other modules, that is from other contracts, the function which is public, and the functions which is private can be called within the module, and the functions which is entry, you can call only via only the transactions. Okay, so it can be called via from an user, or from the from the Node.js backend, or from any backend service that you have. You can call it directly with with a master key that you have. Master key in the sense like the private phrase that I'm talking about, mnemonic phrase. And I'm going to initialize this create this init function with witness argument, and this is going to consume the token. And then what else we need? We need the CTX, which is the transaction context. I will get to in a little bit of what is this transaction context, and it's going to be a mutable one. I will explain what is this in quite a bit. And I'm just seeing. Okay, transaction context in current scope. Okay, in case this is solved. Init functions must have their last parameters as. My system is so slow, so that is the problem. Okay, now next up what we are going to do is we are going to create an icon. We need an icon for the token, right? So it's going to be from this module, and let me just browse through, and let me just browse through and take an icon URL. Okay, so I just got the icon address and I'm saving it. Then what we are going to do is we are going to call the create currency function from the coin module, and it's going to, as we discussed, it's going to return your treasury cap and metadata. Let me use Sui coin and create currency, and this is going to have some quite good number of arguments passed in, parameters. Okay, first one being the witness we have already defined it, and let's consider this decimal should be 9 for now. that standard structure Sui follows is 9. So in EVM we had it 18 decimal format and ERC20. Here any coin it is, you know, the format that they are following is 9 decimals. And the symbol, let's have it something like token, and name as well, token, and the description something or random legit token, at least they can believe, right? And icon URL we have already mentioned it. CTX, which is the transaction context. And what is this? It's squiggly for parameter. Okay. This is its icon URL is expecting of type option. Let me just copy here. Option. We are going to pass in the sum, and internally we are going to pass in the, this is of from the, you know, Sui module itself, URL, and just give me a second. Let me browse through the docs for this URL object. Save, and I pass in the icon URL. So this cannot resolve. Okay, I just need to import it. This is not needed because we are importing it explicitly over there. Okay, 1 second. Yeah, this should remove the warning that it's been showing. I'll just refresh my window. Now, whatever objects that, you know, the structs that we initialized above, we need to initialize, you know, inside the init function. Initialize the treasury object. It says struct treasury D treasury, and we need the ID, which is going to be coming from object module, and new, we pass in the CTX of it. Next up we have the treasury address. I guess that's okay. Treasury val address. And this treasury val address is gonna be something. Okay, I will define it as address for now, and initialize the treasury address here. Yeah, it's just annotating me, and the 0x 1 2 3 for now. Okay, we will replace it with something else. So address invalidated and metadata still contains a value. Yeah, I know it. This is the error that we are expecting, because metadata is of let me show you what it returns. You can see here coin metadata. It returns coin metadata and treasury cap. Since it doesn't have the drop ability, these two objects, it is warning me that I need to make sure that I do something with the treasury cap and as well as the metadata object. Okay, so now what we are going to do is, since I need to remove the thing, I'm going to import the public transfer method, and what I'm going to do is I'm going to transfer this treasury cap to to myself, who is going to deploy the contract. And this is the object that we are talking about, treasury cap, and the recipient is going to be obviously me, and I'm going to initialize the sender here, sender variable here. Let sender is equal to some transaction context, and this is going to have the CTX passed as the argument, and metadata still contains the metadata. That is fine, I know. So here we are transferring the treasury cap to the sender. Expected. Okay, here I need to close. Now what I'm going to do is I'm going to also freeze the metadata. I can make sure that I can transfer the metadata object to myself, but this is the good practice that you need to do when we do a token module. Public freeze object, and I pass in the metadata. Okay, so this is something is done. Treasury still contains a value. The value does not have the drop ability and must be consumed before the function returns. Let me take a look further later. Now let's focus on, we still didn't call the min function, right? So we didn't have it is better to have a mint function in it rather than having it as a separate function. We use the one-time witness here, and this one-time witness can't be created, can't be replicated outside after the module is deployed as well. Okay, so let me call this coin. We have a single function, coin mint and transfer. Yeah, mint and transfer. You pass in the capability, which is our treasury cap, and okay, there's a spelling mistake here. And the amount. I will set a constant here. So constant token supply, which is going to, we are annotating with, it's going to be of type U64, and let me copy the billion numbers. it is. Just took it for reference because I can't type in all zeros. Okay, so this is the 1 billion thing, and I'm going to put it here. And recipient is going to be address. Okay. There is an error coming up. Expected coin treasury a cap. Okay. Setting a mutable treasury. So if I'm passing this, need it this to be mutable, and I pass it as mutable reference here. And it's going to resolve this. Okay. Local variable treasury still contains a value. The value does not have the drop ability. Yeah, okay. Still we didn't. We have initialized this object, but we didn't, do anything with the object. So what we can do is we can also, make sure that we transfer the treasury. Sorry, we don't need to transfer it to me because it's going to be a shared object. Why I am making it a shared object is we can make sure that this treasury can be used multiple in the multiple areas of the token module. I'll say it in the upcoming videos why we made it as shared object. Let me pass the treasury. Okay, so yeah, let me build this. Just check my screen whether okay, it's okay. Let me see, I'll remove the build file. I'm just checking whether that we don't face any compile time error. Okay, what we can do is I'll just tell you what it's going to happen. We are going to create a token, and the token name is going to be let me see, I forgot the structure. The symbol is going to be token, and the name is going to be token, and the description is going to be something a random digit token, and the icon URL you are going to see what it is, some random icon URL in the testnet. Now what we can do is we will replace this with good existing address first. Sweet client addresses, something I need some one address. Okay, I'll just use this one, or let me use this one only, 0x. No, I'll better use this 0xe. Okay, now what we can do is I will check my balance. Okay, that is different token that I've tested before. Okay, it doesn't have any. I'll switch to my main account then. Because to deploy the contract we need Sui coins, right? I just need this account. Yeah. I've switched to this account, and I can test the its it should have the Sui coin, so I'm very sure of that. So what I'm going to do is I'm going to initiate the deployment now. I have it in my history. We are just deploying the contract. Yeah, this is the deployment. Okay, let me walk you through this transaction digest, not entirely, because it has lots of stuff in it. We just have it's already a lengthy video. Let me go through the main ones. So here we have some object called as upgrade capability. Let me I've just copied the transaction digest from my second monitor to this primary one. What I am going to discuss with you guys is, as we might know, I've talked about the upgrade cap right previously. I'm going to find it and okay, see, here it is. And this upgrade cap, we have there is a created object called as upgrade capability, right? Using this upgrade cap, what we can do is we can make sure that you upgrade the contract. If you have a migrate function and as well as some certain criteria to be satisfied, so that you can upgrade your contract in the future. So that is the thing that I need to mention. And in our current token module, we need to make sure that after we deploy the contract, we get this upgrade cap, we pass it in to the function, say delete. In our contract we need to add one in our token contract, and it should be deleted, because why we need to delete it, this makes sure that you build the good relationship between you and your community, saying that we can't upgrade our contract in the future, we can't add any to be more specific, I can't add any supply in future. You just build the credibility between you and your community. That is the thing that I need to mention here. This is one such thing. And let's get into the digest and see something more of our token. Let me switch my screen over here. Just switch my screen and jump to my transaction digest, and as you can see, this is the token that we have deployed, and you can check the description and name and everything here, and the decimals, total supply, when we have deployed it. And let me go through the digest very quickly. This is my sender, this is my deployer address, this is my recipient, this is going to be the recipient which receives the 1 billion supply. And let me go to this guy and see what happened to him. He is having token, this is something 2 tokens, because there was a shutdown in my system. So you can see there is 2 billion which is from our contract being deployed. Okay. So I'll just make a quick note or quick summarize of what we learned today. We learned about witness functions and how it works, and we discussed about one-time witness, and how one-time witness pattern powers up the Sui token module. And this is the things that I need to discuss today. And let's catch up in the next video.